long before Earth existed. Before the Sun ignited. Before the first planets formed. The universe was already writing a story that would one day reach us as faint streams of ancient light. For billions of years, those photons traveled across expanding space, passing countless galaxies before finally arriving at the golden mirrors of the James Webb Space Telescope. Unlike any observatory before it, Webb is designed to look farther back in time than ever imagined. Orbiting nearly 1.5 million kilometers from Earth, protected by its giant sunshield, the telescope detects incredibly faint infrared light that has been stretched by the expansion of the universe. Every observation is more than a picture. It is a glimpse into cosmic history. One of Webb's most remarkable achievements has been the discovery of galaxies that existed only a few hundred million years after the Big Bang. Astronomers expected these early galaxies to be small, irregular collections of young stars that had only just begun to assemble. Instead, several appeared surprisingly bright and unexpectedly mature. Some already contained enormous populations of stars, suggesting that star formation began much earlier and progressed much faster than many previous models predicted. The discovery does not overturn modern cosmology. Instead, it reminds scientists that nature often evolves in ways more complex than our first theories suggest. Every new observation forces researchers to refine their understanding of how galaxies grew during the universe's earliest chapter. The telescope also studies something invisible to the human eye but essential to understanding cosmic history. Light itself carries chemical fingerprints. When that light is separated into a spectrum, astronomers can identify the elements present inside distant stars and galaxies. Using this technique, Webb has detected oxygen and other heavy elements in some remarkably ancient galaxies. These elements could not have existed immediately after the Big Bang. They had to be created inside massive stars before being scattered into space through powerful stellar explosions. Their presence tells an incredible story. The first generations of stars must have formed rapidly, burned through their nuclear fuel, and exploded as supernovae, enriching space with the ingredients needed to build future stars, planets, and eventually life itself. In many ways, these ancient galaxies became the universe's first chemical factories. Every generation of stars produced new elements that would become part of future worlds. The carbon in living organisms. The oxygen we breathe. The calcium in our bones. All were forged inside stars billions of years before Earth existed. After exploring the distant universe, Webb turned its attention to objects much closer to our cosmic neighborhood. Among them were mysterious worlds known as brown dwarfs. Brown dwarfs occupy a strange position between planets and stars. They contain too much mass to be ordinary planets but not enough to sustain the hydrogen fusion that powers true stars. For many years, scientists believed these objects would be relatively simple. Instead, Webb revealed surprisingly active atmospheres filled with water vapor, methane, carbon monoxide, and thick layers of clouds. Powerful winds move through these atmospheres, creating weather systems unlike anything found in our solar system. Some brown dwarfs even displayed changing brightness over time, suggesting enormous storms that can cover much of their visible surface. These discoveries demonstrate that even so-called failed stars are dynamic worlds with their own fascinating environments. Webb has also transformed the study of planets beyond our solar system. Thousands of exoplanets have already been discovered, but understanding their atmospheres remained extremely difficult until Webb began observing them. By analyzing tiny changes in starlight as planets pass in front of their stars, astronomers can identify molecules suspended within distant atmospheres. Water vapor. Carbon dioxide. Methane. Sulfur compounds. Each detection reveals another clue about how these alien worlds formed and evolved. Although none of these observations confirms the existence of extraterrestrial life, they provide valuable information about planetary chemistry and the incredible diversity of worlds scattered throughout our galaxy. Some planets orbit so close to their stars that a single year lasts only a few Earth days. Others follow highly elongated orbits that expose them to dramatic temperature changes throughout their journey. Each new system reminds scientists that our own solar system is only one possible arrangement among countless others. The universe is far more imaginative than anyone once believed. And with every observation, the James Webb Space Telescope continues revealing a cosmos that is richer, more dynamic, and more extraordinary than we ever expected. As the James Webb Space Telescope continued exploring the universe, it became increasingly clear that planetary systems are far more unpredictable than scientists once imagined. Our own solar system appears relatively calm, with planets following stable paths around the Sun. But beyond our cosmic neighborhood, Webb has revealed systems shaped by powerful gravitational encounters, violent collisions, and billions of years of continuous change. Some giant planets travel in highly stretched or tilted orbits, suggesting they were pulled from their original paths by neighboring worlds or distant companion stars. Others orbit astonishingly close to their stars, completing an entire year in only a matter of days. These extreme environments challenge long-held ideas about how planetary systems develop and evolve. One of the most dramatic processes observed by astronomers involves planets slowly spiraling toward their parent stars. Over millions of years, powerful tidal forces can gradually pull a giant planet inward. As the distance shrinks, gravity stretches the planet, heating its atmosphere and stripping away enormous amounts of gas. Eventually, the planet may lose much of its outer layers before finally disappearing into the star that once gave it light. Although this process unfolds over immense periods of time, it reminds us that planetary systems are constantly changing. Nothing in the universe remains exactly the same forever. Webb has also captured remarkable images of enormous disks of gas, dust, and ice surrounding young stars. These vast structures are the birthplaces of future planets. Within them, tiny particles collide and stick together. Over countless millions of years, those particles grow into rocks. The rocks become planetesimals. Some continue growing until they become full-sized planets. Others break apart in powerful collisions, creating fresh rings of debris that future telescopes can observe. Watching these disks is like looking back at the earliest history of our own solar system more than 4.5 billion years ago. Scientists believe Earth, the Moon, and every other planet once formed inside a similar swirling cloud around the young Sun. Webb is allowing humanity to witness those same processes taking place around distant stars today. The telescope has also expanded our understanding of how stars themselves are born. Inside enormous clouds of gas and dust, gravity slowly gathers material into dense regions. As pressure and temperature increase, nuclear fusion eventually begins, marking the birth of a new star. Powerful radiation then pushes away the remaining gas, illuminating spectacular nebulae that stretch across hundreds of light years. These stellar nurseries are among the most beautiful objects ever observed. Yet beneath their beauty lies an environment shaped by gravity, turbulence, radiation, and constant change. Every newborn star has the potential to create an entirely new family of planets. Some of those planets may remain frozen forever. Others may become scorching worlds wrapped in dense atmospheres. A few could possess the conditions necessary for liquid water and, perhaps, life. Each discovery made by Webb adds another piece to humanity's understanding of cosmic evolution. The telescope is not simply taking beautiful photographs. It is collecting evidence. Every spectrum reveals the chemistry of distant worlds. Every observation improves computer models of galaxy formation. Every faint signal helps scientists reconstruct events that occurred billions of years before Earth existed. Perhaps Webb's greatest achievement is not any single discovery. It is the realization that the universe is far more dynamic than earlier generations imagined. Galaxies grow rapidly. Stars are born and die in enormous explosions. Planets migrate across their systems. Black holes shape entire galaxies through gravity. Even the atoms inside our own bodies were created during these ancient cosmic events. In a very real sense, every person on Earth carries material that once belonged to long-vanished stars. That connection reminds us that humanity is not separate from the universe. We are one small part of its continuing story. As Webb continues its mission, new observations will undoubtedly answer some long-standing questions. But they will also create entirely new mysteries. That has always been the nature of science. Every discovery expands the frontier of knowledge while revealing how much remains unknown. The James Webb Space Telescope is not bringing the universe to an end. It is opening a new chapter in our exploration of it. And somewhere among the countless galaxies still waiting to be observed, the next great discovery is already sending its light across space, traveling toward us, one ancient photon at a time.